Hello everyone. Today we are going to learn 2.1 linear first order equation. So we learned last section first order linear equation. Today linear first order equation is the same, right? Just linear is in front, right? Okay, so first order differential equation. So this course is about the differential equation, right? So it's linear, right? So we learned this form last time, right? So y prime makes first order, and we have to have a polynomial, and then y itself form of linear, right? And then f of x, it can be function like the variable x or y. Oh, we cannot have y because y is already there, linear, right? Or we can use any variable t, then it should be of p over t here too, right? Or it could be number, yeah? Or it could be zero. So if we have a zero here, then we called homogeneous equation, right? Since this course is about the differential equation, we say that homogeneous differential equation. I'm using the E, right? Okay, so we learn the terminology homogeneous equation in the linear algebra course, right? Okay, so that means other side has zero. That is homogeneous equation, right? Make sense? Yeah, this one is telling us homogeneous. Yeah, that is homogeneous, telling us, right? Okay, if not, means that if not zero, it can be any function, any variable or number, then it's non-homogeneous equation, right? Yeah, in that case, always we have a non-trivial solution. Yeah, so what is non-trivial solution? In order to know non-trivial solution, we have to know trivial solution, right? So we had a trivial solution, the answer equal to zero, means that zero solution, right? So basically, homogeneous equation can be trivial solution or non-trivial solution. Yeah. Okay, let me write that. So it can be trivial, uh, trivial solution. So what is a trivial solution? The zero solution, right? Or non-trivial solution. That means any number, right? For the solution. So always non-trivial solution. Make sense? Okay. This is a review from the last section. So find the first order equation. Yeah. Okay. So we did everything before. So this is, oh, give us first order, right? So we can see that y prime, y prime, y prime, y prime, first derivative, right? So this one called first order, right? And then we want to find linear. Oh, they don't say the linear, just the first order, yeah? So this is the first order, first order, first order, first order, right? So everything is a first order equation, but they don't say linear, yeah? But which one is linear? We using only, we can see that y, that is a linear, right? So this is a linear. This is not linear because y squared. This is linear. And this is non-linear because e to the y power, right? it should be y in order to be linear. Make sense? Yeah, we went over this one last time. Okay, hold on 1 second. Right. So last time we had y equal to some equation is solution of and given first order differential equation, right? So y equal to solution of that differential equation, and sometimes given initial value, initial condition, right? Okay, this section, we want to find the solution, yeah? That means we have to write out what is the answer for the question y equal to something. Make sense? Okay, let us do this. So we have y prime equal to 1 over x squared. So y prime we can express, right? So y prime dy over dx, yeah? Okay, equal to 1 over x squared. All right, so our goal is solution, which is y equal to something, right? How do we make y equal to something? Because we have a y prime. Yeah, we had the experience, right? So we make integral, right? So take the integral, both sides. Okay. But then we have a little bit issue. We want to make y variable left side, x variable y side. Y side or x variable left, right side, correct, right? Right side. Did I say right side? Yeah. Left side, right side. Yeah. Not the y side, right? I said the y side. Okay. So then we have dy here. Yeah. And then we have a dx there, right? So we want to multiply by dx, both sides. So then we can simplify. So we have only dy left side equal to the right side will be 1 over, let me a little bit move, x squared dx. Yeah. All right. So if we integral left side, what do you get? It's y. Yes. What about the right side, right? What do you get? So we get negative 1 over x. Then plus c, right? Plus c. We call this is general solution. All right. So you guys forget how to integrate? Let me write that. Note. X to negative 2. Then subtract 1 and hold on a second. Is it subtract? It's not subtract, right? It's not subtract. It's add 1, right? Add 1 divide by new power, right? That's the how we do, right? That's how we get that. X to negative 1 over negative 1. Yeah. Make sense? All right. So y equal to negative 1 over x plus c is general solution of the differential equation, which is y prime equal to 1 over x squared, right? Okay, now what if we have initial condition, initial value? So now we have y prime equal to 1 over x squared with y over 2 equal to 1 over 4. This is initial condition. Initial value, right? Okay. So we had general solutions from here. Y equal to, since we have the x variable, so we're gonna have y over x equal to negative 1 over x plus c, right? All right, then it's a given y over 2 equal to 1 over 4. That will be x, right? This will be x. Okay, then y of 2 equal to negative 1 over 2, right? Plus c equal to given 1 over 4, right? Yeah, then we can start for c. Yeah, so solve for c. So c will be 1 over 4 plus 1 half. Yeah, then this will be 4, 1 plus 2, which is a 3 over 4. Make sense? So if we have y of x equal to negative 1 over x plus c will be plus 3 over 4, right? So we call this as a particular solution. Particular solution. So let me, yeah, just leave. Yeah, you guys okay with this? All right, so let us do that. We have an equation, example, find the solution of, this is a differential equation, equal to 0, right? So this is a homogeneous differential equation. Make sense? So this is a homogeneous. Differential equation. Yeah, let me denote D. Okay, and then we have a given initial value, right? So our goal is, like earlier, we want to find general solution. Then by giving initial value, we found the particular solution. Make sense? Okay, let us do that. All right, so we have y prime minus 2y equal to 0. Yeah. So we make all the y variable left side. So let's start with, so y prime minus 2y equal to 0. Now, it's already one side, right? Yeah. But how do we do? We cannot have, so basically, we want to have like a y prime itself in that case. So let us do this. So y prime equal to 2y. Yeah. You might get confused because I said, oh, let's make y variable one side, right? It's already one side, right? Yeah, that's why you might get confused. All right, so we have y prime equal to 2y. Then y is there, right? So we want to divide by y both sides. All right, then we will get y prime over y equal to 2, right? Okay, now look, it will be y variable is one side. Is it clear? We want to make that form. It's not like two terms, all right? Because other side, we have to have something in order to integrate. Make sense to you? All right. So left side, we have y prime, which is dy over dx. We can make that form. And then I want to leave 1 over y, right? dy over dx equal to 2. Now, we multiply by dx both sides like earlier, right? So times dx times dx. So that will be 1 over y dy equal to 2 times dx, yeah? Okay, now we can integrate, yeah, because we have a y variable left side, x variable right side, right? So dy dx. Okay, now let's integrate. So integrate antiderivative of 1 over y, what do you get? Bingo, ln y, right? Good. So that will be ln absolute value, right? So y equal to, then we get 2x. Yeah. All right. So we make a 2x plus c, right? But then let's make a 2x plus k, yeah, instead of c. Yeah. All right. Now we want to solve for y, right? So y is here with the absolute value. Then we have a natural log, right? So we take the e both sides. So let's take the e both sides. And then I just want to copy. Let me just write down. So ln absolute value of y equal to 2x plus k, yeah? All right, then we can simplify, right? Which is y with the absolute value, right? And then look, that will be e to the 2x times e to the k, right? Yeah, we knew that, right? All right, then look, we can say that this is a c. That's why I did not use c earlier. So this will be e to the 2x and c. C equal to e to the k. Make sense to you? All right. So, uh, but then we have y is the absolute value, right? Look, uh, if function has like that, right? So everything is positive. So c will be positive, right? So we will have y equal to, so c e to the 2x power. Make sense? So that is same as y of x equal to c times e to the 2x. Is it clear? Exponential function or as a positive function, right? Okay. Uh, with the initial, let's continue, right? So initial is given, let me do copy, copy. All right. So what is the C will be? Oh, C is e to the K power, right? But then with that initial, right? Okay. All right. So let's do this one. So when x equal to 0, that means, right? So we have y of x equal to c e to the 2x, y of 1, I'm sorry, 0, and then c e to the 2, 0, right? Equal to 1. Yeah. Okay, and so for c, all right, then we have e to the 0 power, which is 1, right? So c and 1 equal to 1, right? C equal to 1. Make sense? Okay, so it will be, this is, let me write down general solution. And if we have y over x and 1, we don't have to write down, so e to the 2k. Particular solution. Is it okay? Okay, so let's take a look at other questions. So we have this differential equation and homogeneous equation, right? Homogeneous differential equation. All right, then we want to find general solution and solve initial value problem. Let us do this one. Okay, so we have x y prime plus y equal to 0, right? Okay, we have two terms. So we have to make one side as a y variable and then other side x variable, right? So in order to make an antiderivative, which is integrate, right? To find the differential equation of solution, right? Okay, so what do you want to do first? Okay, divide by x every term. All right, so there will be y prime plus y over x equal to 0, right? Okay, then, oh, let us do one by one, right? So we can move to the y over x other side. So there will be y prime equal to negative y over x, yeah? Okay, now we keep the x right side. We move to the negative y or y other side, right? So multiply by 1 over y. Yeah. Okay, so there will be y prime over y equal to negative 1 over x. Yeah. All right. So then we almost set it up, right? So we have 1 over y, and that will be dy over dx equal to negative 1 over x. Yeah. Now we take the integral both sides. Then we have 1 over y dy over dx equal to negative 1 over x. Oh, I forgot to multiply by dx. Yeah. And we don't have dx here. And we have a dx right side, right? Okay. What do you get the left side? So natural log with the absolute value y, right? Equal to. Okay. Now, what about the right side? We have the same, right? But then we have a negative sign there. So negative ln uh, absolute value of x. Then plus c. So instead of c, we are going to use a k. Yeah. Why we don't give it to the c here, right? Because we want to solve for in terms of x. Yeah. That's why we give it to the plus c right side. Okay. All right. Now we had the experience how they solve for y. We take the e both sides. Okay. So take the e both sides. So we will have a natural log absolute value of y and e negative ln absolute value of x plus k, right? Okay, then that will be absolute value of y equal to hold on 1 second. We can split, right? So we can split a to the m plus n, which is a to the m, a to the n, right? That's why we can split. So e to the negative ln x, but then we have negative sign we can bring to the power, right? So there will be negative, I want to say that natural log m, which is the same as different color, negative ln m, which is ln m to the negative 1 power, right? Yeah, that property we are using it. Okay, so then we have e to the k power. Then we can, I want to use negative 1 here. Negative 1, yeah? So that I can simplify this one. Next step. So we have absolute value of negative 1, yeah? So there will be 1 over absolute value of x, right? Negative 1 power, right? Okay, then let us give it to the e to the k as c, like earlier, right? Okay, then we have a very simple equation here. So absolute value of y equal to c over not square, absolute value of x, right? Okay, so we have an absolute value, another note, right? So we knew that we have absolute value, then we get the x, positive x, that means all the x value is positive, right? If x is positive, let's make a or equal to 0, right? But then in that case, it's a denominator. So it's or. So make a equal sign there, negative x, if x is less than 0, right? That's why we have absolute value looks like this, right? V shape, right? So that is x, that is the negative x part. Yeah. Okay. Uh, so in that case, all right, so let's talk about absolute value of y, right? So if we have absolute value of y, then same concept. If c is positive or equal to 0, it's a c. If c is negative, c is less than 0. Yeah, makes sense to you? Because we have an absolute value of y there, right? All right, so let's write down. We want to write down this way. The general solution, y equal to c over x. Yeah. And then we want to restrict about the c, where c equal to, we have e to the k, when y is greater than 0, because e to the x power always like that, right? Like this. Never get the 0, right? When c equal to e to the k with a negative sign, if y is less than 0, yeah? So we have positive, then like this, right? Yeah. And then we have the x is a denominator, right? So we will have also the interval notation as well. And also this one too, right? So y over x equal to c over x. And then interval notation, it will be negative infinity, 0, union of 0, positive infinity, right? we cannot have a 0 in denominator, right? Clear? Okay, let's check the answer because it's a little bit complicated. If we have a solution, every time we can check the answer, right? So let's see. Check the solution. Uh, y equal to c over x. Show x y prime equal to x y prime, the differential equation as given earlier, right? So x y prime plus y equal to 0. Okay, so we have y, right? We can substitute. What about the y prime? Yeah. So what's the y prime? C is constant, right? C is constant. And then we drop the power, reduce by 1, right? So there will be negative x to the negative 2, right? With a c, right? So there will be negative c over x squared. Okay, so let's substitute. So we have x, y prime will be negative c over x squared plus y, which is uh, c over x. Is it equal to 0? Yes, right? We can simplify. So we have a negative c over x. We can see the negative c over x plus c over x equal to 0. Yeah, so that is the general solution. Yeah, okay. Now, second part, by initial value, let's find out particular solution, right? Copy. Okay. Oh, right here. Oh no, why didn't I erase? Okay, so we have general solution y over x of y, not over, y of x equal to c over x, right? So we have the general solution y of x equal to c over x. Yeah. Okay, we need to find the statistic, right? All right, so this is x. So we have y of 1 equal to c of x 1 equal to 3. Easy, c equal to 3, right? That's it, right? All right. Um, Then we have particular solution. So we have a y of y equal to c equal to 3 over x. Yeah, that's the particular solution. Yeah. All right. And let me think. All right. So we knew that c equal to 3, right? And also we set it up c equal to something else, right? So c equal to e to the k power earlier, right? Okay, then if we want to know about what is k, right? Let's start for k then. Yeah, this is extra. All right, so we have c equal to 3, and then we had earlier e to the k equal to c, right? And start for k. So we have um, e to the k, which is equal to 3. Then k is in the power, so we take ln both sides then. So there will be e to the k power equal to ln 3, right? All right, so this is simplified. We have k equal to natural log of 3, right? Okay. Make sense? E to the ln 3 cancel out. So we have, we simplify. So 3 equal to 3, right? Yeah. All right. So I brought a graph from your textbook. So look, this is a solutions of differential equation for general, not general, general solution. Yeah. For the differential equation, homogeneous equation, right? Okay, so c equal to 3, yeah? So c is greater than 0, c equal to 3 there. Then solution will be between 0 to positive infinity, right? Make sense? All right, good job. All right, so let's solve this initial value problem. So we have a differential equation here with a homogeneous equation, right? All right, so first order, linear. Y prime plus 1 plus x over x times y equal to 0. Initial value will be y of 1 equal to 1, right? Okay, how do you do? Yeah, so we make x variable is the right side, right? So let us do that. So y prime equal to negative 1 plus x over x times y, yeah, not equal to 0 is y, right? Okay, so if we get rid of y on the right side, everything is clear, right? So let us do that. Divide by y both sides. So we have y prime over y equal to negative 1 plus x over x. That's it, right? Okay, now y prime means dy over dx, and then keep the 1 over y. equal to negative 1 plus x over x. Yeah? All right. Now, times dx both sides. So that will be 1 over y dy equal to negative 1 plus x over x dx. Yeah. Now, let's integrate. Let's think. Okay. All right. Okay, left side, we've been doing this, right? So natural log, absolute value of y equal to, okay, the right side we have negative, simplify with the negative. So first term will be 1 over x and negative, 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 also negative, right? So that will be 1 dx, yeah? Okay, now we can integrate term by term. Minus 1 dx, yeah? Okay, so what do you think? So the first term we have a negative natural log of x and minus x, yeah? And plus c plus k, make sense? Okay, now we want to solve for y. So we take the e, yeah, both sides. So there will be ln x minus x plus k, yeah? Okay, let's just split everything, this power, right? So, and then we had the experience about the negative sign, give it to the power here, right? Okay, let us do one step. So there will be, okay, we simplify. So we have y equal to, uh, we simplify, right? And then x to the negative 1. No, let us make that first. Okay, so e to the ln x to the negative 1, because anyway, I have to write down e to the negative x, e to the k, yeah? All right, I need one more page. All right, then absolute value of y equal to 1 over x with the absolute value, right? And then also e to the negative x, which is e to the x power, right? E to the, in the denominator, right? And then let's make e to the k as a c, right? We did that earlier. Let's c equal to e to the k power. All right. So we had the experience earlier. So y equal to c over x times e to the x power. So it's a general solution, right? So general solution. So where c is, we have e to the k power, right? So positive if y is greater than 0, negative if y is less. All right, now we want to find the particular solution. So we have y over 1 equal to 1. We have okay, so from the general solution, we have so this is x. So there will be 1. C, x is 1, e to the 1 equal to 1, right? So for C. So C is here. We have E here. So we want to make 1. So C must be e to the first power to make 1 for the fraction, right? So e power. Yeah. So particular solution will be y equal to c is e over x e to the x power. That is a particular solution. Make sense? We can use y of x equal to e over x times e to the x power. All right. So we did that several example to find general solution and particular solution, right? So the process is from the differential equation, in that case, we had homogeneous differential equation, right? So homogeneous equation means other side is 0. Yeah, that's the homogeneous equation. Then the process is we want to make y variable left side with one term, right? Two terms we have to move around, right? Then we can make dy over dx eventually, right? And then we multiply dx. So other side is we can make all the variable x term, right? Or constant with dx, yeah? Then we can find antiderivative, which is we can find y, right? Then given information with initial value, initial condition, we can find particular solution to find such a C. Make sense? All right. This one is a little bit different. I'm gonna explain to you the terminology integrate factor. Yeah. Okay. So we have this question. So we have integral of cosine x ln x plus sine x plus, I'm sorry, sine x over x dx gives that sine x times ln x plus c. Yeah. This one is hard to think. Without this, yeah, just given this one, what should we using that? Yeah, it's hard to think, right? Integration by part, how they find, yeah. But it's a given. the answer, right? Then it's easily to check solution, right? So let's check that whether this one antiderivative integral of this one or not. Yeah. So let us do that. How do we check? Derivative, right? Yeah. So let's derivative, check the solution, check the answer. Check the answer. Okay. So we want to derivative sin x, ln x. Yeah. Okay. It's a product. So we can use a product rule. So we have fg prime, f prime g plus fg prime. Yeah. So we are using same letter, the first derivative with the second derivative, right? This is more easily to understand and remember, right? Okay. So in that case, what's the derivative of sine x? Which is cosine x, right? So cosine x and g plus sine x. What's the derivative of sine? I'm sorry, ln x? 1 over sine, right? I'm sorry, 1 over sine. 1 over x, yeah? Okay, good. So 1 over x. Yeah, can you see that? So we get exactly same as this one. Yeah. So cosine x, ln x plus sine x over x dx. Yeah. Okay. What I am trying to tell you, we have uh, y prime, right? So y prime plus p over x, y equal to f of x. What is the form? What is the form? What is called? Very good. So we call this is a first order linear or linear first order, right? So first order linear. Yeah. Okay. Now, uh, if we want to derivative of something times y. Okay, once again, product rule, right? Copy. So there will be the something prime y plus something y prime. Yeah. Okay. Then we're following here too. So what if we have derivative yeah, I'm gonna change y here, right? Since y is y. Derivative respect to y, yeah? Because we are using y variable here of mu times y. Okay, so note with mu in Greek letter, right? So product rule again. So that would be, let me make a little more. So that would be mu prime, the first letter, mu prime, y plus mu second prime, right? So y prime. Yeah. Okay, now uh, we have the form of first order linear. That will be that one. Yeah. Copy. Okay. Then this one I can express y prime we can express, right? We knew that y prime will be dy over dx. And plus, just copy exactly what they have, right? Okay, now I want to multiply by mu of x every term in that case. So there will be mu of x plus mu over x, mu over x. Yeah? So let me just copy down every term here. And f of x. Yeah. Okay. Now, look. Can you see that this is mu y prime? Because y prime we can express as a dy over dx. Yeah? Can you see that? So let me write down. This is mu y prime and let me see. And then I want to make like this. So since we have this is mu y prime, so I want to make this one as here. So let me see. So then mu prime y, yeah. Okay, then we can say that. We can say mu of x, p of x equal to mu prime of x. Make sense? We just want to make that. Yeah. Make that form. All right. Now I want to isolate the p of x. So that will be we divide by mu of x, both sides. So there will be p of x equal to mu prime of x over mu of x. Yeah. Okay. Now we do integrate both sides. So integrate. So p of x equal to mu prime of x over mu of x. Okay, now what do you get this one? Okay, so think about this one. So left side, we can use p of x as it is. Then the right side, we will have, oh. So once I want to make a integrate, I want to make a dx, yeah? All right, so hold on 1 second. Think like x prime of x We don't say the x prime over x, right? Over x dx. What can you say? Can you say that? Okay, maybe this is not the good example. Um, yeah, it's better we writing out this way. Derivative of x. How about that? Yeah, because you might not think correctly. So we have that, and that's the natural log of x. Yeah, let's see. Make sense? Okay, so in that case, we have ln absolute value of mu of x plus c there. Okay, now we have a natural log. So we take the e, both sides, exponential function, right? So yeah, hanging there because I'm trying to get the integrating factor. Okay, so that will be p of x equal to ln mu of x plus c. Okay, so we have any constant, so let's ignore for now, right? So it's a constant. So let's ignore that. Okay, so we have e to the integral p of x equal to, we have absolute value of mu sub x. So we have e function always have the positive, right? So only the positive. Okay, now we call this is integrating factor. Yeah, integrating factor. So when do we use? Like earlier, we had a nice differential equation to find general solution with a given initial value to find particular solution, right? But then if there is more difficult, it's not simple, then we are using integrating factor to find integrate. Yeah. Okay. So let us do one question. We finish, and then we're gonna keep doing that for by using that technique, integrating factor. Make sense? Okay, let us do that. Last question for this section. All right. So find the general solution of, okay, so earlier we had homogeneous, nice equation, right? So here we don't have homogeneous, non-homogeneous, right? Okay. And then we cannot find nicely one side with one term, y variable, other side is just x, right? Okay. That we using integrating factor, all right? Okay, so look, this is a form of, so y prime linear order, linear order, first order linear, right? So y prime plus polynomial y equal to f of x, yeah. So polynomial, it can be constant or it can be function, right? Okay, now we have mu of x, yeah? So we had mu of x equal to e to the integral of polynomial dx, yeah? So polynomial will be 4, right? Make sense to you? x equal to e to the p of x. X. E to the p of x is 4 dx. Yeah. What's the integral of 4? It's a 4x. Yeah. So we get e to the 4x plus c. Yeah. I have a habit all the time plus c, but we don't need that here. Okay. Now, we multiply by e to the 4x every term. So we have dy over dx plus 4y equal to e to the 5x. And then multiply by e to the 4x every term. Yeah. Okay. Now we have e to the 4x dy over dx plus 4y e to the 4x and e to the 4x e to the 5x. Yeah. Okay. So this one, we need the e to the 9x. Yeah. A different color. All right. Then let's check that. Okay, so I am following same processing here. So we had that mu sub mu over x, right? Okay, let's check that whether product rule here is there too, right? So let's check that. Check. Check the product rule. So we have derivative and then e to the 4 dx y. Then there will be mu, right? So this will be mu sub x. Yeah. Then we have fg, which is f prime g plus fg prime. So there will be hold on 1 second. Before we do that, we have e to the 4x earlier and then yeah. Okay, now derivative of e to the 4x for e to the 4x, yeah? Y plus e to the 4x and derivative of y dy over dx, yeah? Okay, now we have this one here and then we have this one here, right? Okay, then we say that they are equal to e to the 9x. Can you see that? So that will be equal to e to the 9x. Make sense? Because they say that here. All right. Now, what we are doing. So this will be mu sub x, y, right? So we have derivative e to the 4x y equal to e to the 9x. We want to solve for y, right? Okay, so we have a derivative, and then we have a y here. So we make antiderivative, right? Antiderivative both sides if we want to, right? Okay, then, so it will be e to the 4x, y equal to, and right side will be anti. So anti, we keep that and divide by new power, right? Yeah, instead of multiply, we divide, right? Okay, plus c. All right, so y is there, so we divide by e to the 4x. So there will be y equal to 1 over 9, e to the 9x, and divide by, right? So, which is 5. Plus, and c over e to the 4x. Yeah, that will be general solution. It's a lot of steps, right? But you can do it. All right. Thank you for watching. I'll see you in the next video. Bye.